Here's another tutorial video on power series solution of second order linear differential equations. If you haven't seen the beginners video in the playlist, make sure to do so before you continue with this. For our first example, it says solve the equation d square y over dx square plus dy dx plus 2xy equals 0, given that at x equals to 0, y is equal to 0, and dy dx equals to 1. So the first step is to rewrite the differential equation in this format. That is y subscript 2 plus y subscript 1 plus 2xy equals 0. Now we apply the Leibniz theorem, which says the n derivative of a function is equal to u subscript n multiplied by v plus n multiplied by u subscript n minus 1 multiplied by v subscript 1, and it keeps adding up in the series. So this is our first term in the formula, second term, and third term. Now for the first term in the equation, y subscript 2, we need to identify our v and our u term. Our v is the coefficient, which is 1, and the first derivative will be equal to 0 because the derivative of a constant is equal to 0. Now our u is equal to y subscript 2. The n derivative of u will just be the addition of the numbers in the subscript, that is n plus 2, y subscript n plus 2. And we'll stop there. Now we'll apply the formula for the first term, that is just multiplying u subscript n multiplied by v, and we get y subscript n plus 2. Now for the second term, y subscript 1, our v is also 1, and our v subscript 1 is equal to 0. Our u is equal to y subscript 1. U subscript n is just equal to what? Y subscript n plus 1. Now when we combine it in the formula, we get this y subscript n plus 1. Now for 2sy, our v is equal to 2s. That's the algebraic term. On the first derivative of 2s is equal to 2. The second derivative is equal to 0. We don't need that. Now our u will be equal to the y function, and our u subscript n is equal to y subscript n. Now we need to get u subscript n minus 1 because in my v we stop at v subscript 1, so we need to get to u subscript n minus 1. So now just substitute n minus 1 into the function of u, that is what? Y subscript n minus 1. Now when we combine it using the formula, we have y subscript n, which is equal to u subscript n, multiplied by the value of v, which is 2s, plus n multiplied by u subscript n minus 1 multiplied by 2, and that gives us 2s multiplied by y subscript n plus 2n multiplied by y subscript n minus 1. So the next step is to combine the differentiated terms, right? So we add everything together. This is the solution for our first term, second term, and this is for the third term, equals 0. Now at s equals to 0, we substitute the value of s as 0. So any factor that has s in it, we cancels out, right? This cancels out, so we have just y subscript n plus 2 of 0 plus y subscript n plus 1 of 0 plus 2n multiplied by y subscript n minus 1 of 0 equals to 0. Now the next thing is to what? Make the highest derivative the Pareto formula, because we have three derivatives here. We have n plus 2, n plus 1, and n minus 1, and obviously y subscript n plus 2 is the highest. So when I make this Pareto formula, we have this y n plus 1 and the subscript n minus 1 goes to the left hand side. We can factor out negative sign from the right hand side to get y subscript n plus 2 of 0 equals to minus open bracket y subscript n plus 1 of 0 plus 2n multiplied by y subscript n minus 1 of 0, which gives us the recurrence relation. The next thing is to plug in values of n. And I wrote that substituting n is equal to 1, use an equation with y subscript 3 on the left hand side, this one. Also, when we substitute n is equal to 0, it results to y subscript 2 on the left hand side. And y subscript 2 is lesser than y subscript 3, which means we need the value for y subscript 2 also. But using the value of n as 1 on the right hand side gives a direct value of y of 0, which is one of the initial term, if you understand what I mean. Now, when we start from n is equal to 1, substituting 1 into the formula, we have y subscript 3 of 0 equals to minus open bracket y subscript 2 of 0 plus 2 multiplied by y of 0, because y subscript 1 minus 1 is the same as just writing y of 0. Now when we substitute n is equal to 2, we get this. So the formula says y subscript n plus 1, that is now 2 plus 1 equal to 3, plus 2n, that is 2 times 2, which is 4, and y subscript n minus 1, 2 minus 1 is what? 1. So we have y subscript 4 of 0 equals to minus open bracket y subscript 3 of 0 plus 4 multiplied by y subscript 1 of 0. To get the definite solution of y subscript 4 of 0, we need y subscript 3 of 0. And to get the definite value of y subscript 3 of 0, we need y subscript 2 of 0. So when n is equal to 3, we get this also. Y subscript 5 of 0 equals to minus y subscript 4 of 0 plus 6 multiplied by y subscript 2 of 0. We can recall that y subscript 2 plus y subscript 1 plus 2sy equals 0. That is the original question, with a boundary condition that at s equals 0, y is equal to 0 and ds dy equals to 1. So y is equal to 0, it can be written as y of 0 equals to 0, and ds dy can be written as y subscript 1 of 0 equals to 1. Now I can make y subscript 2 of 0 the set of formula. We have minus y1 minus 2sy. So when you substitute the value for y subscript 1 and the value for y, we got y subscript 2 of 0 equals to minus 1. Now I wrote out the values for y of 0, y subscript 1 of 0, and y subscript 2 of 0. We can now plug in these values into the higher derivative function. So y subscript 3 of 0 equals to this function minus open bracket y subscript 2 of 0 plus 2 multiplied by y of 0. Now we have minus open bracket y subscript 2 of 0 equals what? Minus 1 plus 2 times y of 0 equals to what? Just 0. So y subscript 3 of 0 equals to minus 1, which is equal to plus 1. Now for y subscript 4 of 0, we have this function also. We plug in the value for y subscript 3 of 0, which we just got as 1, plus 4 times y subscript 1 of 0, which is 4 times 1. So I have minus multiplied by 5, that is minus 5. Now for y subscript 5 of 0, we get this function minus open bracket y subscript 4 of 0 plus 6 multiplied by y subscript 2 of 0. Now plug in the values, I am left with minus open bracket minus 5 minus 6. So that is equal to what? Plus 11. Now substitute this higher derivative into the Maclaurin series formula. Since I stop at y subscript 5 of 0, so I'll be stopping at y subscript 5 of 0 in my series formula also. And here is the formula. It says that y is equal to y of 0 plus s multiplied by y subscript 1 of 0 plus s square over 2 factorial multiplied by y subscript 2 of 0 plus s power 3 over 3 factorial multiplied by y subscript 3 of 0, and we keep adding up in the series until you get to wherever you want to stop. Now substitute the value for y of 0 is equal to 0, so I have y is equal to 0 plus s multiplied by y subscript 1 of 0 is equal to 1 plus s power 2 over 2 factorial multiplied by y subscript 2 of 0 is equal to what? Minus 1 plus s power 3 over 3 factorial multiplied by what is y subscript 3 of 0? We got 1 plus 1. For the next term, we have y subscript 4 of 0 is what? That is equal to minus 5. Okay, and the last one is what? Y subscript 5 of 0 is equal to 11. So now when we simplify, we have y is equal to, this 0 cancels out, s times 1 is what? S. The negative sign multiplied by the positive s is power 2, we have s is power 2 over 2 factorial. We don't need to expand the denominator since there's a pattern. Now plus s is power 3 over 3 factorial. So, okay, we have minus 5 s raised power 4 over 4 factorial plus 11 s is power 5 over 5 factorial. And that is the answer for our example 1. For our second example, we have determine the general series solution of the equation s squared plus 1 multiplied by y subscript 2 plus s multiplied by y subscript 1 minus 4y equals 0. So this has been given in the general form. We don't need to convert the differential equation. So we apply the Leibniz theorem. For our first term, the n derivative of our first term equals to this. You can do it on your own to confirm. So we have s is power 2 plus 1 multiplied by y subscript n plus 2 plus 2ns multiplied by y subscript n plus 1 plus n raised power 2 minus n multiplied by y subscript n. And for the second term, the n derivative of it is equal to this also, using the Leibniz theorem formula. And for the third term, minus 4y, and the n derivative of minus 4y is equal to minus 4 multiplied by y subscript n. Now we'll combine the differentiated terms. So I wrote out the first term here plus the second term, y subscript n plus 1. I notice this appears twice, so I wrote the next one, which is what? Plus s multiplied by y subscript n plus 1. And for our y subscript n, it appears 3 times. So we have this, this, and this. So that's why I have plus n is equal to minus n multiplied by y subscript n plus n multiplied by y subscript n minus 4 multiplied by y subscript n equals 0. Now when we'll simplify the y subscript n plus 1. So we have s is common, so we'll be left with 2n plus 1 as a factor or a coefficient. Now for our y subscript n, we have this n square minus n plus n. So plus n minus n cancels out, so we'll be left with what? N square minus 4 multiplied by y subscript n equals to 0. Now we'll substitute the value of s to get our recurrence relation. So when we substitute the value of n, s equals to 0, so for this one, s squared plus 1, we just have 0 plus 1 is what? Is 1. 1 times y subscript n plus 2 remains as y subscript n plus 2. But for this second term, it cancels out, because s multiplied by this will cancel out as 0, right? So we'll be left with y subscript n plus 2 of 0 plus n raised power 2 minus 4 multiplied by y subscript n of 0 equals to 0. So when I move this one to the left hand side, to the right hand side, because y subscript n plus 2 is the higher derivative, so my recurrence relation can be written as what? Y subscript n plus 2 of 0 equals to negative sign. We are using this negative sign to open this bracket. We have 4 minus n raised power 2 multiplied by y subscript n of 0. So this is our recurrence relation. And for our n values, we can start from 0 to just get, when we substitute 0 here, we have what? Our y of 0 as our initial term. So when n is equal to 0, we have from the formula y subscript 0 plus 2 of 0 equals to 4 minus n square. Now n is equal to 0, right? So that is 4 minus 0 square multiplied by y of 0. So now y subscript 2 of 0 is equal to 4 minus 0 is just 4, and we have this also. So y subscript 2 of 0 equals to 4 multiplied by y of 0. When n is equal to 1, we get y subscript 3 of 0 on the left hand side. And for our right hand side, we just do 4 minus 1 square, which is 3. So we have 3 multiplied by y subscript 1 of 0. When n is equal to 2, we have y subscript 4 of 0 on our left hand side. And for the right hand side, we have 4 minus n square, which is 4 minus 2 square. 2 square is now 4. 4 minus y is what? 0. 0 multiplied by the other function is what? 0. Now when n is equal to 3, we have y subscript 3 plus 2, which is 5 on the left hand side. Now we have 4 minus 3 square, which is 4 minus 9, we get minus 5 multiplied by y subscript 3 of 0. So I can write it as this, minus 5. Y subscript 3 of 0 can be equal to what? 3 multiplied by y subscript 1 of 0. That is minus 5 multiplied by 3 multiplied by y subscript 1 of 0. Now when n is equal to 4, we have y subscript 4 plus 2 of 0, which is y subscript 6 of 0. So for the right hand side, we have 4 minus n square, which is 4 minus 4 square. Now 4 square is 16. 4 minus 16 is what? Minus 12. Minus 12 multiplied by y subscript 4 of 0. And y subscript 4 of 0 is also equal to 0. So that gives y subscript of 0 as what? 0. Now when n is equal to 5, we have y subscript 5 plus 2, which is y subscript 7 of 0 on our left hand side, is equal to 4 minus 5 square. 5 square is 25. 4 minus 25 is what? Minus 21. Multiplied by y subscript 5 of 0. And y subscript 5 of 0 is equal to what? Minus 5 multiplied by 3 multiplied by y subscript 1 of 0. So when I plug in that into y subscript 7 of 0, we have 21 minus multiplied by minus is positive. So we have 21 multiplied by 5 multiplied by 3 multiplied by y subscript 1 of 0. You must be wondering why I extended my values of n equals to 5 for this example. I did that because when n is equal to 2, I got a value of 0 or a solution of 0. And when I did n is equal to 3, we got a definite value other than 0. Now when I did n is equal to 4, we also got a 0. So I was like, okay, let me do one more to check if there is a pattern to it. And y subscript 7 of 0 also gave me a definite value other than 0. You can stop at n is equal to 3, n is equal to 4, n is equal to 5, or the examiner instruction. Now we'll substitute those values into Maclaurin series. And now Maclaurin series will be stopping at x power 7 over 7 factorial multiplied by y subscript 7 of 0, because the highest derivative here is what? Y subscript 7 of 0. Now doing that, y is equal to y of 0 plus x multiplied by y subscript 1 of 0 is the same thing. We'll repeat it. Now plus x power 2 over 2 factorial, we can now extend the denominator, which is 2 times 1. Y subscript 2 of 0 equals to, we'll represent it by the value 4 times y of 0, plus we do the same thing for the next term. Y subscript 3 of 0 is equal to what? We have 3 multiplied by y subscript 1 of 0 as that, and we'll also extend the denominator, which is 3 factorial, 3 times 2 times 1, plus when we do that for the next term, x power 4 over, when we expand the denominator, 4 times 3 times 2 times 1. Now y squared 4 of 0 equals to 0, which means that particular term will cancel out, plus x power 5 over 5 factorial is what? 5 times 4 times 3 times 2 times 1, multiplied by value of y squared 5 of 0, which is now this, plus y squared 6 divided by 6 factorial also, which is 6 multiplied by 5 up to 1. Now the value for y subscript 6 of 0 is equal to what? 0. And for y subscript 7 of 0 divided by the denominator also, we extend it, and now these are the value for y subscript 7 of 0. Now we simplify. Y is now equal to, the first term remains the same, the second term remains the same. Now for the third term, 2 cancels out in the numerator, numerator, and we are left with 2, because 4 divided by 2 is what? 2. So that is what? Plus 2x raised power 2 multiplied by y of 0. Now for the next term, 3 cancels out in the denominator, we are left with 2 at the denominator. That is the same thing as writing 1 over 2 multiplied by x raised power 3 multiplied by y squared 1 of 0. Now for the next term, 0 cancels out this particular term. The next one, we have x raised power 5 over 5 factorial, right? For the 5 factorial, 5 and 3 cancels out in the denominator, we are left with what? 4 times 2, which is 8. And the numerator has a negative sign, that is minus 1 over 8 multiplied by x raised power 5 multiplied by y squared 1 of 0. Then the next term also has a 0 in the as a factor, so it cancels out. The last term here, we have 21 times 5 times 3 in the numerator, and we have 7 factorial in the denominator. So let's do that. 6 times 5 times 4 times 3 times 2. So that is 5040. And for 21 times 5 times 3, that is 21 times 15, right? Let me cancel this. So that is 315. So I want to check if 315 is a factor of 5040. So we have 16, which means the numerator cancels out in the denominator, and we will be left with 15 in the denominator. Is it 15 or 16? 16 in the denominator. So that is what? Plus 1 over 16 multiplied by x power 7 multiplied by y squared 1 of 0, and you keep it keeps adding up in the formula if you continue with your values of n. Now when we factorize, you can factorize out all the values for y of 0, and factorize all the value for y subscript 1 of 0. Now y is equal to y subscript y of 0 open bracket. We'll have 1 left here when I factorize y of 0 out. Then we also have this plus 2x squared plus, okay, that's all for our y of 0. Now for the other one, plus y subscript 1 of 0 open bracket, we are left with s as a coefficient here. We also have 1 over 2 of s power 3 as a coefficient. We have minus 1 over 8 multiplied by s power 5 plus 1 over 16 multiplied by s power 7, and it keeps adding up also. That brings us to the end of this video. If you haven't watched the previous videos in the playlist, endeavor to do so. If you have any question, drop it in the comment section. Like, subscribe, and share with your friends. Also, I'll be dropping the download link for this file in the description section. Bye.